Welcome. Today, question 7. I think last class I told next class will be T section. No. Before that, I remembered one zigzag pattern, important for concept. See, like angle section. See, you can see one angle here, one more angle here. You can see one more angle here this way. This shape, this type of lamina practically will not come, but it will give you complete control on moment of inertia. See, same question I had taken earlier for centroid location. So, I decided first to solve that question, question 7. Title you can see there, very important for concept. Okay, start. Question. Find moment of inertia about the horizontal and vertical axis passing through centroid. The question is, you have to find horizontal axis passing to centroid. I told XX. Vertical axis passing to centroid, YY. So IXX, IYY required. And see, and hence find. See, once they given hence find, what it means? See, question is hence find. Oh, you should think then. Hence find means you first find I about XX, I about YY. Hence find means using that result, find moment of inertia about, see, PQ and RS, two randomly given axes. They can give wherever they want. They can give it top edge or bottom edge, right vertical or left vertical, somewhere given. Okay. So question is, first you have to find I about centroidal axis, and then lastly, using that result, you have to find I about PQ, I about RS. Now, so I wrote here, required to find what? Moment of inertia about all this I told you, IXX, IYY, and then using this, that is already calculated IXX, IYY, we have to find IPQ, IRS. I will tell you how. PQRS given in the question, the person randomly given, gave. First step is to locate centroid G. Why? Make a note now. If you want, first you have to find IXX, IYY, that is horizontal axis, vertical axis pass into centroid G. First step is to locate centroid G. Now note, very, very important. If you correctly did not observe this one, you will have trouble. See, this lamina is the same as that given in part 3. We are in part 3 only, lecture 18. At that time, we are in centroid. Question number 5 at that time. I wrote at that time, question 5, very important for concept of question 5 of locating centroid. In the bracket I wrote, very important for concept. Today also I will write question 7, of finding moment of inertia in the bracket, very important for concept. Now, once this question number 7 and one more coming up now, 8, once it is completely clear, you will have firm grip on parallel axis theorem, all the concept. See, triangle, semicircle, circle, still pending. Okay, now, something in the class I will tell. See, now this, if you do not go through everything I tell, suddenly skip and go to next part, you will not understand. You will regret then. See, therefore, see, class. First, we have to locate centroid. For that, the given lamina, it will be divided into parts. See, 1, 2, 3, 4. We will divide into 4 parts. Consider reference axis OX and OY, usually bottom left corner. I told Ebelco, if I remember earlier. And find X bar, Y bar. Now write here. It is, class, very, very thoroughly explained, complete sketch here. Each and every term, X bar equal to A1, X1, A2, X2, etc. up to A4, X4, divided by total area, Y bar, A1, Y1, A2, Y2, etc. Everything systematically done in the part 3, lecture 18, question 5. Therefore, what you have to do now is, see, what you have to do is, first go to part 3, lecture 18, question number 5. See, there, when you divide into parts, see, You will divide, movie like this you will divide. Some dimensions are required. You have to get all dimensions for all the rectangles using the given data. How to get it? See, how to get this distance or anything. For example, for you require, suppose you divide like this. How to get this distance? Using given data. Everything is thoroughly explained there. And remember that first you have to understand, correctly do, and finally there x bar. From where x bar I will tell you. This is x bar, y bar. I noted down my class. X bar, y bar you got there. So therefore till here, till you get x bar, y bar there, you class refer which one? I told, where is it? Part 3, lecture 18. So therefore, what I will do now is, I will divide into parts here, but I will not explain. I will tell you correctly refer earlier and get x bar, y bar. Or you can do one thing. Those who got a capacity need not refer. Understand correctly how I divide here. That's all. Then you do your own calculation and x bar, y bar. I will be happy. Because that means what? You got a grip, control. If you have difficulty, you refer there. So my question will continue from this step onwards. So now that lamina divided into 4 parts with all the dimensions and x bar, y bar calculation, I will write in the board here, but then I will show you, then I will temporarily, for some time, I will show it and then rub it out. Okay, I'll continue. Okay, as I told, I wrote a neat sketch here. See, from the given lamina, this 215 is not given. Even 260 also is not given, I think. Some of them are not given, but using the dimensions given there for each rectangle, see this rectangle 30 by 150, this rectangle 25 by 260, this rectangle 15 by 165, this rectangle, this is 20 by 125 from here up to here, and total overall is 370, total vertical is 360. This all thoroughly explained there. Actually it is high school mathematics, but still you refer there and make a fair copy. Okay, then part number 1, see, I decided this is the part number. I'll put a part number here. Okay, part number 1 somewhere here. Part number 2, centroid comes here, no problem. Part centroid comes where? Here. Part number 3 and part number 4. I'll divide into parts. Then A, X, see, you have to write, consider bottom left extreme corner origin, O. Abelco, extreme, Abelco I told earlier. So from there, X this way and Y this way. This X and Y are not centroidal X, X, Y, Y. This is reference axis. So this way X distance, so X distance from OY, Y distance from OX. X to right side, Y to upward, everything, see, like for this one, X1, 30 by 2, here, 260 by 2, for this one, 30 plus 215 plus half of 15. This all I should not waste time now. That class, part 3, lecture 18, each and every term was thoroughly explained. Actually there, after some time, I even took origin here and found this X bar and this Y bar. That is not required now. Only one X bar, Y bar. So that way you prepare the table, total area is there. So finally X bar to right side from OY equal to A1, X1, A2, X2, etc. by total area y bar from OX, A1, Y1, A2, Y2, etc. You got these two answers there. Now, class, something I'm telling now, class. Once you got these two answers, that time it was location of centroid. What I have done is, see, I made a rough sketch here. Original diagram, whatever given original diagram. Then I wrote the overall dimension here, and then I located the x and y, centroidal axis there. I wrote this x bar, I found from this distance, I wrote what is this distance, and then this distance, I located g. Because that time question was to locate centroid, right? But here, purpose is not, question is to find moment of inertia. Therefore, once you get x bar, y bar, that xx and yy axis passing to centroid, you have to locate in this diagram. So now right here, class, go back to our main diagram. Locate x bar, how much you got? 144.362. See here, this is 260. 260 by 2 is 130. From here to here is 130. We got 144. So this way, slightly after G2, not too much more. How much more? 144, 130. Okay, I'll shift G2 here. Space problem. Okay, G2. Okay. Therefore, slightly after this one, see, exact scale not required. This is one of the axis. Locate here. This is your YY axis. And see, dimensions are there. X bar I locate here. This distance is your x bar equal to 144.362 millimeter. I'll put YY here. YY. Now, very important. For moment of inertia, we also require distance from here. Okay. From there you calculate. I told you how to calculate that one. That will be from 370, subtract this distance and write here. How much it is? Actually, already there in the class only it is there. In the photo is there. I took a photo of the old class. 225.638. It is my own class. 225.638. 638. Remember, it is calculated value. Okay. Then, from here, OX axis, y bar this way. See, this way. There is no place right here. Free space is there. I shift that x little that side. X, go that side. Okay. Then, see, from here, y bar, how much you got? 178. See here. 20 plus 165 is 185. But you got 178. Little below. See. 178. Okay, no problem. Reasonable scale, exact scale not required. Okay, this is your x-axis. And we got, see here, extend further. X-axis. This is your y bar. Whatever you got. This is your y bar. Y bar equal to 178 point, I don't know camera, 178.087. If requirement is there, I'll shift the camera, 0.87. Then also find from this top extreme edge, this distance. That is from total 360, subtract it. In the photo I can see it, 181.913. I took the photograph of that one. 181 point, see, some will tell, wow, who is this person who will forget so fast? See, forgotten. How much I told? 181 point, forgotten. 181 point, 913 millimeter. If requirement is there, shift the camera. See, if it is not visible right now, I will shift the camera slightly. I'll check it. I think okay thing. Its space is there. Okay, space is there. I maintained the space. Yes, correct. Okay, no problem. Now, see, everything over. This is your centroid G for the entire lamina. This is your x-x axis. This is y-y axis. Horizontal axis passing to centroid. Vertical axis passing to this one. And remember, total area is 15975. I require it. I'll write somewhere here. Total area 15975. I require later. 15975. Okay. Now everything is ready. Now see, this table I will remove. Okay, correct. 144.362. Okay, everything correct. Okay, all correct. See, by chance, by mistake, if any writing mistake is there, you by chance, if anything is values are wrong, you correctly understand procedure. You take wrong value only. Okay, now next step. See, next step is calculation of moment of inertia. I put short form inertia about xx and yy centroidal axis. That is, you are finding I about xx and I about yy. Use parallel axis theorem. Parallax theorem. Okay. Now I write here. Use parallax theorem. First you write this statement. I am rubbing it now because I want space. I am rubbing because I want space there. I got how many moment of inertias? 1, 2, okay. Yes, okay. Okay, I'll rub it out. I want space. Okay, write this much. Then write. Is that top portion visible? That 370? I got doubt. Yes, visible. Okay. Now write. Okay, I told what all I wrote you should write. I am rubbing because space problem for me. Okay, right here now. By parallel axis theorem. See, this I should not explain now. I, red color, I about any axis equal to this repeatedly I told Ig plus area into h square. What is Ig? What is area? What is h? I explained so many times. Now if anybody, if it is not clear, you better skip my classes. Okay, start. First, calculation of Ixx. What you do is you calculate I about xx for figure number 1, for part number 1, then calculate I about xx for part number 2, I about xx for part number 3, and also lastly I about xx for part number 4. Everywhere formula is what? Ig plus ah square. See, equal to. Start. Everywhere first term is Ig. Okay. Everywhere first term is Ig. Okay, I'll do one thing now. Writing is black. See here. We want I about xx axis. Start here. First I about its own centroidal axis parallel to xx is this axis. 30 into 150 cube by 12. 30 into 150 cube divided by 12. Goes Ig over plus area. 30 into 150 is the area. Okay, only black I use. Into, this is the most important, into perpendicular distance from centroid to xx axis is here. From here to extreme here is 181.913. 181.913. We want from centroid to xx axis is 181.913 minus half of 150. Minus 150 by 2, that is to be whole square. Calculate this answer. Okay, then start. Figure number 2. I want I about xx axis. First I about axis passing to centroid parallel to xx, this axis. Parallel side 260. 260 into other is 25. 25 cube by 12 plus area. 260 into 25 is the area into the most powerful term from centroid of the component to the required axis perpendicular square is 181.913. We want this distance minus 150. See, 181.913 minus 150 minus 25 by 2. It's so clear, easy to understand. Minus 150 minus 25 by 2 whole square. Calculate this answer. Okay, then figure number 3. I about its own centroidal axis. Parallel side 50, perpendicular side for that rectangle 165. So 15 into 165 cube, 165 cube divided by 12 plus area. 15 into 165 is the area into the most powerful term from centroid to this axis. See, this perpendicular square, that is 178.087. 178.087. See here, from here to here we want 178.087 minus this distance 20 minus 20, again minus from here to here is 165 by 2. See, correctly understand whole square. Calculate this answer. Next, lastly, I about xx for fourth one. First about its own centroidal axis. Not 110, see, for this rectangle, parallel side is 125. 125 into 20, okay. 125 into 20 cube divided by 12 plus area. 125 into 20 is the area into from centroid of the component to the required axis perpendicular square is 178.087 minus half of 20 by 2. 20 by 2. See, from here to here is this distance minus 20 by 2 whole square. Calculate this answer. Then do one thing. Therefore, Ixx for entire lamina equal to, you write here, I about xx for 1 plus I about xx for 2 plus I about xx for 3 plus I about xx for 4. For 1, for 2, for 3, for 4, all of them known for you. See, everything is known here. Substitute and get the answer in 10 to the power 6 millimeter power 4. This is the final answer for Ixx. Okay, now I want values for this question. There's a reason for it. I want the answer. There's a reason. Calculate it. Okay, I calculated all the values. See, I write in terms of 10 to the power 6, and that number I will take to 4 decimal accuracy. That's important. So therefore later one check is there. There slight last number variation can come. Okay, leave it now. See, I got the answer here, 4 answers. Adding all, I got 153.1347 10 to the power 6. Now you can make a note. Suppose they want radius of gyration about x-axis axis. It is root of this ixx divided by area, that is 15975. You get rxx if you want. Okay, now calculation of Iyy. I'll fast right now. So first I'll do one thing. Iyy. Okay, so Iyy for 1, Iyy for 2, Iyy for 3, Iyy for 4, then finally Iyy equal to Iyy for 1, Iyy for 2, Iyy for 3 plus Iyy for 4. Okay. Now this will change. I'll change it. Don't worry. But remember, area will not change. Number will change. Okay. Area will not change. Why should I change the area? Number will change. Number will change. This is to save the time. But you should not do this way. Okay, I'll put later. Okay. Okay, start. Correctly start. I about Yy. Parallax theorem, start. Figure 1. We want I about Yy. First, I about its own centroidal axis, see here, which is parallel to Yy. So, parallel side 150 into 30 cube by 12. 150 into 30 cube by 12. Plus area, 30 into 150 or 150 into 30, whatever you want. Okay, already there. So, I write 30 into 150 area into from centroid to Yy, see, red color, this distance square. That distance equal to, see, from here to here is 144.362, 144.362 minus 30 by 2, minus 30 by 2 whole square. I will calculate later because I have to do carefully. Okay. Iyy for figure number 2. See, this one. Its centroid is here. First, I about its own axis. See, this question will give you perfection in the moment of inertia calculation. People don't understand. They have no patience. Those who are still correctly going on here, remember, this is how you develop the strength or concept. First, I about its own axis. Parallel side 25 and other side is 260. 25 into 260 cube by 12. 25 into 260 cube divided by 12 plus area, 260 and 25 is the area into, see, this distance square. That distance square is 144.362. That is distance from where? From here to extreme end here. Yes, exactly midpoint. Minus 260 by 2. Minus 260 by 2 whole square. Okay. Over. This also over. Figure number 3. First, I about its own centroidal axis and parallel to Yy. Now we are doing I about Yy. For this one, parallel side is 165. Okay. 165 into how much thickness there? 50, 165 into 15. Thickness is here, 15 into 15 cube by 12 plus 15 into 165 area into from centroid to this axis, this distance square. See, this distance square, that distance equal to 225.638 See, very important. See, we want from G3 to here, this distance we want. So 225.638 minus, come up to only here, minus 110. Don't come up to here. 225.638 minus 110 and again minus 15 by 2. Minus 110 minus 15 by 2. See, such a concept you should understand. Minus 15 by 2 whole square. Last one for this one, I about its own centroidal axis. Parallel side, how much? 20. Okay. 20 into, how much that one? 125. Okay. 125 cube by 12 plus 125 and 20 is the area from centroid to this axis. See, this distance square, that is 225.638 minus this distance is half of 125 minus 125 by 2 whole square. Calculate all the answer, add it, and finally get the answer. I want to make a note somewhere. Okay, I'll make a note. Okay, I'll calculate. Okay, I calculated. See, I got of everything I calculated here, wrote the answer. I made a note there. Area 15975. IXX, how much I got? 153.1347. 212.3791. Okay, I made a note. I require it. Now, make a note what all I dictate you write. Then only you will learn. We got moment of inertia about centroidal axis. Some statement I am writing now. See, these all will make you perfect in concept. If you are lazy and do not go through all this one, you are losing, that's all. Now statement you are right. See, don't see here. See, some dictation I will give you, important statement. We got moment of inertia about centroidal axis for the given lamina. In the question they told moment of inertia about centroidal axis, that is IXX and IYY. Then they also asked you, using that, find I about PQ and RS. I think PQ is here, RS is here. How to find? Once again use parallel axis theorem, but this time do one thing. For the complete lamina, you do not divide, take as a single unit, because you know the properties, right? Now you know where is centroid for the complete lamina and what is moment of inertia about centroidal axis. I told this earlier. So therefore, so now see, I write here now, somewhere here. Okay. Now, to find second part of the question, see, second part of this question, actually very, very important. To find I about, okay, I'll put red letter, I about PQ and I about RS. PQ and RS shown in figure, shown in the question, are using what? Using already calculated calculated moment of inertias about centroidal axis. That is using IXX and IYY already calculated. So for that, what you do is you write the sketch once again. Note, now do not break into parts. Rough sketch. See, a rough sketch. 150. Little bigger. Okay, no problem. Rough sketch only. It's a given lamina. See, you consider the entire lamina as one unit. See, entire lamina as one unit. Single unit. Do not break. Single unit. For that one, not red color, I will use green color now. Centroid is somewhere here. See, slightly here. Okay, centroid is here. G. Then there is one axis here passing through centroid. Horizontal axis, one vertical axis. These axes I will call small xx and small yy. Small xx and small yy. Reason is there because this is going to be component for parallax here to understand. And then see, write the distances. This distance, see, we got a full outright distances required. Full outright distances are, see, full distance, full not required. Okay, wait, no. Now xx, okay, xx, where you got this distance, see. This distance is how much? 178.087, and from here properties, this distance is 181.913, whereas this distance, that is 225.638, and this distance is out of scale. It is little actually out of scale. Okay, 144. I can't redraw the sketch once again. Okay, 144.362. That should have gone a little bigger. Okay, no problem. Don't worry about those things all. Out of scale. This is centroid G. See, centroid G. Now, for this we know what? For this, see, area, I will put small a. Actually, the small a is right here, earlier capital A. How much area? 15975. 975 mm square. And I about this xx axis. That is our earlier I about xx. But this time about its own axis. How much answer I wrote it down? 153.1347. 153.1347, 10 to the power 6 millimeter power 4. And I about yy axis, small yy, its own centroidal axis. This was actually our earlier capital Iyy. But now we are taking this as a component. Okay. This is how much? 212.3791. 212.3791, 10 to the power 6 millimeter power 4. Okay, now do one thing. Correctly mark those two axes required. One of them is PQ. See, our PQ is here. They want I about PQ here. Your RS is here. This is RS. Okay. Now find I about PQRS. Okay, I'll remove this one now because that sketch I don't want to remove. There's a reason. This diagram I do not want to remove. Okay, now see. Right. By parallel axis theorem, what is theorem? See, I about any axis equal to, it is green color I am using to understand, I about Ig plus area into h square. Right here. Moment of inertia about its own centroidal axis parallel to required axis. Area considered h, perpendicular distance from centroid to the required axis whole square. I already told everything earlier. It is not first time. It is actually 1000th time I am telling it. Okay. Now see here. Therefore, see correctly. I about PQ equal to, see, start. If you want I about PQ, come to centroid. For complete lamina, I about its own centroidal axis parallel to PQ means I about this axis. Oh, that is 153.1347 10 to the power 6. That is your Ig. See, this is Ig parallel to PQ. That is here Ixx. It was earlier I capital XX plus area. Area of the entire lamina is 15975. 15975 is the area into, see, perpendicular distance from centroid to this. This is YY. Okay, YY come this side. Okay. To what? Perpendicular from here to this axis is, see, this distance square. That distance is 181.913 whole square. Make a note here. Suppose instead of PQ giving here, if they give PQ through bottom edge, same procedure, distance square is 178.087. Okay. Get the answer you get in 10 to the power 6 millimeter power 4. This is I about PQ for the given lamina. Directly using Ixx, Iyy. Once again not required to calculate. Okay, this is 153.1347 10 to the power 6 plus 15975 into 181.913 square equal to divided by 10 to the power 6. 681. Answer is this color problem. See, I will tell the students, you have got subject confusion, I got color confusion. What to do? All color getting mixed up. Sometimes it happens. Okay. Struggling for color. Actually, my calculator is not in good position. That's why I should be very careful. 681.7848. 7848. 10 to the power 6. I will make a note. I require it. 681.7848. I require it. Little later. Okay, 10 to the power 6 is the answer. Now, after that one, write everything over. Now write next. I about RS. See here. I about RS. First, I about, if you want I about RS, what you have to do? Once again, same principle. You want I about RS. See, this RS. This axis. First, I about an axis passing to centroid parallel to RS is this axis. That is your IYY here. 212.3791 10 to the power 6 plus area is same into from centroid to RS. This distance square is 225.638 whole square. Calculate. Or make a note here. Suppose your RS is given here. Distance square is 144.362 square. Okay. 212.3791 10 to the power 6 plus 15975 into 225.638 square. 1025 1025 1025.7064. 7064. I want that answer. 10, where is it? 1025.7064. Okay. 25.7064, correct? 7064, correct. 10 to the power 6 millimeter power 4 is I about RS. Okay, now our question is completely over. So I can as well wind up the class. I am not winding up the class. There's a reason for it. When you learn completely. I told master question. Therefore, now I will do one thing. Question is over now. Question number 7 over. See. Now I will go for question number 8. I will tell you what is the question number 8. See. I first write the question here. Question 8. Very, very important. Don't ignore question 8. I will tell you what is question 8 before rubbing the board. Question 8 is same as question 7. They will not ask I about centroidal axis. They will ask directly I about PQ and RS. In that case, you don't have to locate centroid, don't have to find IXX, IYY. What you do? Directly, whatever sketch given, divide into parts and enjoy moment of inertia about PQ and RS. My guarantee, what answer we got just now, it will come. But of course, see, 23791, 3788, that's all. I'm helpless because rounding off is there. Minute error will come. That is in 1 lakh rupees, 1 rupee, 2 rupees, no problem. Because if you want that also exact answer, you have to write endless number here. See, you can't write 178.087, 178.1. Actually, the number is, I'll tell you the number. Or for that matter, I'll tell you this number. It is 144.3622848, I think. See, if you write that way accuracy, answer will tally. That way not required. So, minute 1 lakh or 2, 3, 4 lakh rupee transaction, some 1 rupee, 2 rupee, nobody bothers. So that because of rounding off, that error will come. I will do one thing now. I will write the question, write the solution, and single recording, I will complete it. Now I will start the question. I forgot to rub it out. Okay. Question 8. Make a note. Those who want to understand everything, both questions are required. Question is, find moment of inertia about PQ and RS for this given lamina. All dimensions are in millimeter. Somebody will tell, it's already solved. No, independent question. Okay, start. First make a note. Divide the given lamina into different parts. This you already told. Suppose you got difficulty, how this 150 came. That all I explained earlier. Or I told earlier, see how to get the all these dimensions. This I told you. Actually high school mathematics. Okay, over. Part 1, part 2, part 3, part 4. Then they want moment of inertia about PQ and RS. There is no need of finding IXX, IYY, moment of inertia about centroidal axis. Or, see, no need of locating G right here. X bar calculation not required, Y bar not required, that IXX not required, IYY not required. Directly start finding moment of inertia about PQ and RS. How? Using parallax theorem. Make a note, little earlier we located XXYY, found IXXIYY, moment of inertia about centroidal axis. Then using that and parallax theorem, we got considering entire lamina as one unit. Okay, now not that way. Okay, now this I will remove. I can remove this one? Yes, very much. Okay, start. I'll remove this one now. Start. Right. See, sketch is already there. Actually, I maintained the scale. I removed. See, don't see this one now. This is not for you. This is the noted answer. What I got just now, I noted the answer. Okay, now start. Calculation. Okay, see, now calculation of moment of inertia. I always use red color. See, calculation of I about PQ and I about RS. Use, right, first. By parallaxis theorem, I about any axis equal to IG plus area into H square. You write what is the meaning of H, what is the meaning of IG, what is the meaning of area. Start. Now first calculation of I about PQ. Start. Calculate IPQ, again IPQ, again IPQ, again IPQ for part 1, part 2, part 3, part 4. Start. Equal to. See, mark PQ here. Red color. This is your PQ. Start. First, come here. I about its own centroidal axis, parallel to PQ. 30 into 150 cube by 12. 30 into 150 cube divided by 12 plus area. 30 into 150 is the area into from centroid of the component to PQ. See, now about PQ you require. This perpendicular square is 150 by 2. Very simple. 150 by 2 whole square. Calculate it. Then IPQ for 2. First about its own centroidal axis. See here, this one. Its own axis parallel to PQ. 260, correct, into 25 cube by 12. 260 into 25 cube by 12 plus area. 260 into 25 is the area into from centroid of the component to required axis. See, this perpendicular square. That is 25 by 2 plus another 150. 25 by 2 plus another 150 whole square. I about PQ for figure number 3. First about its own centroidal axis parallel to PQ. Side is 15 and 165. 15 into 165 cube divided by 12 plus area. 15 into 165 is the area into from centroid to here. This distance square is, see, this is 165. 165 by 2 165 by 2 plus 25 plus 150 whole square. I about PQ of fourth one. See, I about its own axis. 125 is the base. 125 into 20 cube divided by 12 plus 125 into 25 is the area into from centroid to here. See, from centroid, this distance where directly you can do 360. See, 360 minus 20 by 2 directly. 360 minus 20 by 2 whole square. Calculate. See, get this answer, get this answer, get this answer, get this answer. Then write. Therefore, you do it. Now I am not doing it. Therefore, IPQ for entire lamina equal to I about PQ plus I about PQ plus I about PQ plus I about PQ, I about PQ for 1, I about PQ for 2, for 3, for 4, everything is known. Calculate all, add all the values and get the answer in 10 to the power 6 millimeter power 4. I will do single stretch. Single stretch I will do it. 30 into 150 cube divided by 12 plus 30 into 150 into 75 square plus 260 into 25 cube divided by 12 plus 260 into 25 into 12.5 plus 150 square plus 15 into 165 cube divided by 12 plus 15 into 165 into 165 by 2 plus 25 plus 150 square plus 125 into 20 cube divided by 12 plus 125 into 25 into 360 minus 10 close square. What is the answer I got there? I got some other answer. I think there is some calculation mistake. 1 minute, I will calculate one second. I will calculate one second. Okay. I calculated 3-4 times, answer was not tallying. See, mistake, the thief is stole, see, caught the thief then. 150 by 30, 260, 25. This is 125 by 20. I wrote by mistake 25 here. See here, it is not 25, it is 20. See, one small mistake, see what happens. Everything is gone. Everything is correct. See, I took 20 by 2 only. See, distance also I took 20 by 2 only, but by writing area, by mistake I put 25, that's why not tallying. Okay, now I got the answer. See, this one, this all answer, 681.7856. And make a note here, note. Earlier answer, when we considered, first we found moment of inertia about centroidal axis, then transferred it to PQ, we got answer of 681.7848. 7848. Now you got 681.7856. Oh, what is this? 7848 is 785. See, I told this is because of the decimal accuracy, rounding of error. That means perfect answer we got. Okay, now lastly, I about RS. I will finish now. A single stretch. Single stretch I will do it now. I about RS. Okay, first usual RS. RS, RS, RS. See, this is very boring trait. RS, you write this time. This time you write I about RS equal to I about RS for 1, I about for RS for 2, I etc. etc. You write. See, for 1, for 2 plus for 3 plus for 4, you write. At least some work for you. Okay. Now, you can't do this way. Okay, I'll do one thing. Why unnecessary struggle? I'll rub and write once again. This is okay. This I'll maintain. Who will unnecessarily waste time by rubbing number by number? Then sometime one number gets not changed, then error will come. Okay. Start. Now, I about RS. Same. See, start. I about first, figure number 1. We want what? We want about RS. Okay, do one thing. PQ is not required now. Now you require RS. Mark RS. Where is RS? RS is here. See. This is your RS. Up to here you can extend it. Start. First, come here. Come to centroid. I about its own centroidal axis parallel to RS. Now 150 into 30 cube by 12. 150 into 30 cube by 12 equal to plus area. 150 into 30 is the area into from centroid here to this RS, see, this distance square, that is equal to how much? 370 minus 30 by 2. Red color. Into 370 minus 30 by 2 whole square. Calculate this answer. Next. Second one. I about its own axis parallel to RS. 25 into 260 cube by 12. 25 into 260 cube by 12 Ig plus, this is 150 actually, 25 into 260 is the area into from centroid to here this distance square, that is 360 minus, see, from 360 subtract 260 by 2. 360 minus 260 by 2 whole square. Or you can do one thing. 110 plus 260 by 2 whole square. Both are okay. Calculate this answer. Figure number 3. I about its own axis passing to centroid parallel to RS. 165 into 15 cube by 12. 165 into 15 cube by 12 Ig plus area 165 into 15 is the area into, see, from here to this centroid, this distance square is 110 plus half of 15. Very easy to understand. 110 plus 15 by 2 whole square. Get that answer. Lastly, I about RS for fourth one. See, about its own axis first. 20 into 125 cube by 12. 20 into 125 cube by 12 plus area 20 into 125 is the area into from centroid to RS, this distance square is 125 by 2 directly. 125 by 2 whole square. Then finally get the total answer. Okay, I don't want to pause. Directly I will do now. 150 into 30 cube divided by 12 plus 150 into 30 into 370 minus 15 close square, 10 to the power 6. 567.45, 10 to the power 6. Next time I won't put unit here, millimeter power 4. Okay. Second one, 25 into 260 cube divided by 12 plus 25 into 260 into 360 minus 130 square. 380.4667. See, since I am doing 4 decimal, that difference came. If I do for third decimal, same answer would have come. Next, 165 into 15 cube divided by 12 plus 165 into 15 into 110 plus 15 by 2 square equal to divided by 10 to the power 6. 34.21. You can make out as the area is coming near and near to the axis, moment of inertia is decreasing. As the area is away and away from the axis, see, moment of inertia is increasing. 34.2169 for those who want to concept. Okay, last answer. 20 into 125 cube divided by 3 over. That is 13.0208. 13.0208, 10 to the power 6. Add all the values. 13.0208 plus 34.2169 plus 567.45 plus one more is 380.4667. 995. How much answer I got there? I got 1000. Something wrong. Again, when I do calculation, this calculator problem. Some problem in the calculator. Okay. Then I will pause. These things always happen. That's why I always first calculate. Okay. I have done calculation correctly. What happened is, see, this is 360, this is 370. When I took for second one, see, I told this distance square is, I told 360. I see 370 minus 260 by 2, but by instead of 370, I took 260 here. See, one small mistake sometime. It is 370. See, this I used wrong distance. I told correctly. Then when I went there, I thought it is 360. 370. See, 370 minus 260 by 2. Number is changed. It is coming 1025.7044. Remember, little earlier, same answer we got 1025. See, I still maintained it. 0.7064. 0.7064. 1025.7044. 1025.7064 means 0.002. 0.002. In what? In this such a number. In around 1025, 0.002. Or in 10250, 0.02. Earlier 0.02. In 102500, 0.2. In 1025000, 2. 10,25,000 rupees transaction, 2 rupees difference. Nobody will bother. Okay, that's for fun I told. Okay, so now question is completely over. Little lengthy class for your benefit and for making you perfect. These examples are taken. Next class I am going to T section. Okay, thank you. We'll meet in the next class. Completely go through the class and understand.